Hello, I hope you all are doing very well. In this video, we are going to see chi-square test very effectively with the help of an example also, but let's learn from very basic, from very scratch, so that you can learn each and everything of chi-square test. So let's begin. The chi-square test is a non-parametric test. We have already discussed in previous sessions that what are parametric test and what are non-parametric test. So non-parametric tests are the test where they does not make any kind of assumption about the distribution of the data. Here also in chi-square test, it does not make any kind of assumption regarding distribution of data. That is why it is a non-parametric. And because of this property, we can say that chi-square test is a versatile test because it can be used with a variety of data types, right? Now, it is a statistical test which is going to be used for comparing observed value and expected value, right? So when we are having the distribution of data, we have some observed data and we have some expected data, right? We are going to solve some examples. Here you are going to see that what I am talking about later on, right? So the comparison between observed value and expected value is tested with the help of this statistical test, that is chi-square test. It is used to determine whether disparity between actual and predicted data is due to chance or is there some link between the variables under consideration. So that is going to be figured out with the help of this test. Now, the chi-square test can be used to test two different type of hypotheses. The first one can be goodness of fit. It is like this hypothesis test whether the observed frequency of a categorical variables are consistent with the hypothesized distribution or not. So whatever hypothesis made by the researcher, is the data, is the distribution data, is the observed frequency of the data is matching with or not, is consistent with that data or not. So hypothesis is matching with consistency of the distribution of data or not. That is goodness of fit, right? So this is one kind of hypothesis which can be used by chi-square test. So for example, you could use chi-square goodness of fit test to test whether the observed distribution of political party affiliation in a sample is consistent with the distribution of political party affiliation in the population. So whatever sample we have taken and whatever the complete population is there, so whatever affiliation is there in the sample is matching, is consistent in the complete population or not, because sample is a small size data and this population is a large size or universe size data, right? So whatever consistency we are making in this sample should be consistent with the large size, right? So goodness of fit can be tested with the help of chi-square test. And the second one is independence. This hypothesis test whether two categorical variables are independent of each other or not, right? So for example, you can use chi-square test to test the independence of any two variables, like distribution of eye color is independent of the observed distribution of hair color or not. In a particular sample, if you are observing the distribution of eye color, then that eye color is independent of hair color or not, right? So to relate the independence between any two variables, we can use this independent test, or we can use this chi-square independence test. So this two kind of hypothesis can be tested with the help of this chi-square test. Normally it is represented with this symbol, right, as you can see here. Now some assumptions are there for chi-square test, and the assumptions are like data must be categorical, right? We are going to see the examples where you can learn it, that what do I mean with the help of that data must be categorical, right? The second one is the expected frequency in each cell of the contingency table must be greater than 5. So expected frequency of each cell in contingency table must be greater than 5, and data must be independent. If any of this rule is violated, then the result of this chi-square test would be unreliable, right? Basically, it is a very powerful tool to test the hypothesis, and it is used in variety of data. It is used in variety of data. A normal formula, as you can see here, is chi square. This C is nothing but, you can say that, the freedom of data. This is observed data, and this is our expected data, right? So whatever data is observed, we need to subtract expected data from it, and we need to make a square of it, and we need to divide it with the help of expected value, and we need to sum up all the data with that, right? So this is a general formula of chi-square test. So guys, I hope whatever I have discussed in this video is clear. In next video, I am going to take a very important example, and with the help of that example, you are going to learn this chi-square test more effectively. But before discussing this example, I hope this discussion was necessary, right? So please subscribe, do stay tuned with us for more such important lectures on research methodologies and other topics. And if you are having any doubts, confusion, queries, feel free to ask in the comment section. And you can also watch the previous lecture with the help of link which I have provided in the description section, guys. Have a very nice day. Jai Hind, Jai Bharat.